In this video, we're going to take a look at finding the equation of a tangent line. In this example, we're going to take a look at not a function, but what's an equation here, I guess is what we'll call it. And so in this example, we'll have to take the derivative implicitly here to find the equation for the tangent line. Okay, so just like before, the derivative is going to give us the slope of the tangent line. We're just going to do that implicitly. And what we'll need is the two values here, 0 and 1, when we do that, right? So 0 is the x value here, and 1 is the y value of the point that they give us. Okay? So that's slightly different than the other problems where we're just dealing with functions. There, all we needed to do was take the derivative and plug in the first coordinate. Here, we'll have to plug in the first coordinate for x and the second coordinate in for y. Okay? All right, so our equation was this. It's not solved for y, so we are going to take the derivative implicitly, right, assuming that y is a differentiable function of x here. Okay, so when we take the derivative, right, we would go through this left side. The left side is three functions being subtracted and added together, right? So we can use the sum and difference rules on those. So first off, the derivative of x squared would just be 2x. And then I would subtract off the derivative of x times y. Well, x times y is a product rule problem, right? Even though it may not look like it, but remember how implicit differentiation works, right? Y is taking the place of some more complicated function of x. So I have x times some other complicated function of x. That's a product rule. So to do the product rule, first thing I'm going to do is take the derivative of x and then leave y alone. And that's where this term right here came from. I didn't bother really to write the 1 because 1 times y just comes out to be y. Okay. Then the product rule says put a plus. And then it says whichever function you took the derivative of the first go round, which was x, just rewrite it. So that's what I did right there. And then multiply by the derivative of the other one. All right, well, y is some function of x, but again, I don't know explicitly what that function is, so all I can do is put the symbol here, dy dx. Take the derivative of y with respect to x right there is what you would do. So everything in parentheses is the derivative of x times y right here. Next, I would add the derivative of y cubed. So that would be a chain rule problem because y is taking the place of some more complicated function of x right there. So I'd use the power rule on it first, right? That's sort of the derivative of the outside. So I'd bring this 3 down, drop this power by 1, right? And then leave the inside alone. So I have 3y squared. And then the last step of the chain rule says to multiply by the derivative of the inside part. Well, I don't really know what the derivative of, I don't really even know what the inside part is, right? Whatever y would be equal to if you solve this thing, that's what it would be. But I don't have an explicit formula for that, so I'm just going to put this symbol right here to complete the chain rule. Hey, if you ever figure out what y is, then multiply by its derivative right there. Okay? So that's the complete derivative of the left-hand side. I also need to take the derivative of the right-hand side. The right-hand side is just the number 1, which is a constant, so its derivative is just 0 here. Okay? So I have taken the derivative and I could solve for dy dx algebraically and then plug in 0 and 1, but I don't really have to do that. I can just plug in 0 and 1 right now and solve, right? I only have to figure out the slope at 0, 1, just a single point, so I might as well just go ahead and plug those values in for x and y and then solve that out. So that's exactly what I'm going to do. Plug in the 0 for x, plug in 1 for y, and that's what I would have. Okay. So now just simplify as much as possible. 2 times 0, right, is going to wind up to be 0. Then I'm going to subtract off. Inside the parentheses, right, I have 0 times dy dx, so that's going to be 0, right, because anything times 0 is 0. Then add 1. Right, so inside parentheses here I'd get a 1, so I'm subtracting off a 1, and then 3 times 1 squared will just be 3, so that's what I get. And of course 0 minus 1 is negative 1 plus 3 times dy dx. all that's equal to 0. So next what I would do is add 1 to both sides of the equation and get 3 times dy dx equals 1, and then divide both sides by 3, and I get dy dx is equal to positive 1/3 here. Okay. All right, so now I have the derivative, and that gives me the slope of the tangent line. I was already given the point, so now I would just go to the formula for the tangent line, y minus f of a equals f prime of a times x minus a, right? And a was 0, f of a was 1, and then the derivative, right, even though we use this different format here, it just goes in the same exact spot right here once you find the derivative, so 1/3. And then they want the answer in slope-intercept form, so just go ahead and simplify that out, and when you solve for y, you get y equals 1/3 x plus 1. That's the tangent line. So I also have a picture of this one here. Desmos does a good job of graphing out these equations here, and so that's what the equation would look like, right? And here's the point that we're looking at, 0, 1. Okay, and the tangent line, y equals 1/3 x plus 1. So when I graph it out, and again, it has exactly that same behavior right there. The tangent line just kind of skims along right there at that point. And so even though we don't explicitly know what y is as a function of x, we can still find an explicit formula for the tangent line right there at that point.